traditionally looking after cybersecurity. But a year ago, we said we wanted to start a DevSecOps division, and they let us do that. So it's something that we're very passionate about, and we love giving out some more information about it and getting people excited about it. DRS has been going for over 20 years with lots of experience in cybersecurity. I think from that point of view, it gives us a lot of insight into the risk and security point of view. And then, with the DevSecOps side, it's just now getting used to the developer role going into it. We also have Audrey Farson, who is the sales manager for DRS, on board. She's on the line tonight, and she actually gave us some nice prizes for tonight. So thank you very much. And just wanted to make a special apology for Adam. Unfortunately, he's off sick. He's in hospital at the moment, so he won't be able to join us. But he did record his session, which is really, really good because he's our developer. So I really can't do that part. I can answer questions, but I can't do that part. So I do have recording. It's not as great as having him online, but you'll see it's still very good. Shalom, maybe just want to do an introduction on Protec, which is our sister company in Kenya that actually introduced us to SheX.
Thank you very much, Franco. Shalom Onibe here. I'm the head of assurance services for Protec. And an intro to Protec. Protec has been in the cybersecurity business for the last 23 years. We headquarter here in Kenya, and our branches spread across East Africa majorly. And one of our visions is to ensure that in times of uncertainty, we bring stability and peace of mind to people who consume our services. So you can agree with me that COVID-19 is a time of uncertainty. And even till now, the world is still trying to prepare for what's coming next, even where we're not sure what's coming next. So now more than ever, our vision statement tests our ability to deliver services for our clients in the region and across the world. So yeah, that's a brief nutshell about Protec, serving the Kenyan landscape and beyond. Over to you, Franco.
All right, thank you very much. Okay, guys, I'm going to do a presentation on DevSecOps. I'm firstly just going to do a broad overview of what is DevSecOps, why is it important, before we jump into Adam's part of showing you what our CI/CD looks like, how we look at the security within our pipeline, and just a bit about our lab and how it works. So I think just to set the scene, if you guys want to unmute and say something, it's great. Let me know. If you just want to ask some questions in the chat, please do so. But I wanted to start off, can anyone tell me what DevSecOps means? What is DevSecOps environment in your company? Anyone willing to give it a go? See, there's someone on the chat. Right, okay, so the reason I ask if anyone wanted to say is because DevSecOps is a different meaning for everyone. If I go to a certain company and I say to them, okay, you guys are doing, well, let's take it a step back. Let's go to DevOps. Forget the sec part. We're doing DevOps. If I go to a company and saying you're doing DevOps, what is your DevOps strategy? Where are you? It's different for each company. Everyone understands and says what DevOps is different. It is development and operations working in sync, yes. But that could be for one company spinning up cloud instances. For another one, it's from source code to back-end systems. So for everyone, it's a different thing. So that's why it's so wide encompassing, and we want to go through just some of the basics for you guys. So this is quite nice because it shows you the old DevOps infinity sign where we plan, code, build, test, release, deploy, operate, and monitor. And then we have DevOps. So this is how there's peer delivery, security involvement at the end of the process. So the problem with this process is security was done between test and release. So you would do maybe a pen test, or if you're lucky, a DAST test, but you would only be doing it here. So if you pick up any security flaws, you have to go back there and start over, and back there and start over. So you never get to your CI/CD, which is continuous integration, continuous deployment. So this is why it's so important. Now, there are there's this one where you get the security added on. So it is there, but it's not as integrated to the level where we actually want to be. But for a first step, this is good to get to DevSecOps. But ideally, we want to be here. Now, I think just to give you a quick overview there, this is where we start looking at stuff like SAST. Does everyone know what SAST is? Or let me just go through. SAST is your static analysis, where DAST is your dynamic analysis. So this is where we're actually going to the code that the guys are writing. So when you're developing a new application, whether it be backend, front end, whatever application you're developing, it needs to check the code. Now, I'm going to go quickly through this because at the end there's a slide that actually that shows it a lot better. But this is so important to have these gates at each step. When we're planning to do threat modeling, when we're developing to do secure coding, when we download code out of the third-party libraries, where there's Mathis, Central, GitLab, to make sure what we're downloading, to check our internal code, to check the compiled apps. Once we start putting the gates in everywhere here, then security becomes the responsibility of each developer, of each person. So we're pushing the security left. We're saying that everyone should be responsible for security, not here at the end before we release, now we do security. If we do it here, it's not only going to make your code so much more secure, but also you'll start, your release cycles will start getting shorter and shorter and start deploying faster and faster. Because think of it this way, it's plan, develop, build, test, security flaws, go back. Now we're fixing it as we're going through the cycle. So by the time we get here, there's a very few stuff that we're going to pick up and have to fix. So it will make your development life cycle so much faster. And then you get to the true DevSecOps infinity. Now in DevSecOps, we're looking at 4 main pillars: governance, people, process, and technology. And they're all equally important. We have certain governance stuff that we need to follow and make sure that we from a security team check everything, make sure that it's correct. And if the developers aren't on board, we keep asking them for stuff and they tell us they've done it, but we don't really know because it's all code and different stuff. So, you know, from a governance point, we need certain things to make sure that we're doing it right. We made sure that the people are all aligned in talking to each other. So we have security champions and that everyone is responsible for security. Once we get the processes right and we know how we're going to do it, who's going to be responsible for which sections, then only do we look at what technology do we buy. So the governance, people, and process, when all of that's in place, then we look at technology. Now there's lots of amazing technologies out there, but that needs to be the last step, not the first step as lots of people do. Just to show you how a development lifecycle works, we plan, we develop and code. This is very important here. This develop and code area is where a lot of the vulnerabilities and stuff gets put in. And that has to be tested on many different ways. Then we build. Now the build is where we put the application together. You've got many different developers writing sections of code. Somebody needs to put that together at the end into a compiled application. This is what we talk when we say the build phase. Testing is not just security testing, but your functional testing, your UAT, everything that you test. Then we release and deliver, deploy, operate, and monitor. Now the monitoring section here also becomes really, really important in DevSecOps to make sure that the app is behaving the way it should and not just putting a WAF on. Yes, WAFs are very important, but it doesn't check if the app is behaving wrong. So I'm just going to go through this very quickly. The planning phase encompasses all aspects of software design, planning and management, including configuration management, change management, project management. And the important part from a security point here is the threat modeling and the abuse case development. We need to have this when we start planning. If we don't do threat modeling when we start planning, we're in trouble. When we go to the development code part, this is where we actually write the code that goes there. Now, an important part to remember here is when we're writing code, developers are lazy. They will go to third-party libraries and get code that's already written and put it in. So when we're saying develop and code, that also means taking code from third parties and put it into your code. So here it really is important to have secure coding practices, VM container hardening, and your IDE security plugins. It really is important here. Then we have the build phase. In the build phase, it really is important for us to have a SAST and an SCA. This is extremely important. The SAST is the part that actually looks at the source code that we write, static code. So the code we write, it looks at that. The SCA, now this is the fun part, the software composition analysis, and it's important to remember that name, is where we actually scan the external code that you download. It's really important to understand that when we download code, it might not just only have a vulnerability in it, but it can also have licensing requirements that could really affect you. In the testing phase, here's where your DAST, your IAST, your fuzzing really becomes important. Penetration testing will always be important. Even if we have all the other tools in place, you're still going to have to do a penetration test. The idea of having all other tools in place is so that we don't do penetration testings that often, or we can focus on more select parts. So then we have the release delivered. Here it's really important to do the code signing and release packaging tools, making sure that it's automated and that no one is manually doing any of this. Deploy, this is where we do this post security scan and the automated infrastructure provisioning. This is very important, as well as the data masking and encryption. Very, very important, especially with the new governance and data laws in most countries. In the operate part, this is where we'd have a RASP and a WAF, which is very important. The RASP is your runtime application security protection, and the WAF is a WAF. So that is a normal WAF that you put on. Then you monitor. Really important to always keep monitoring what you're doing. So where is this thing looking? I can see the correct slide here. Hold on. Sorry, one moment. I'm just going to do this because I'm not sure why it doesn't want to display. Okay. So what I was mentioning earlier is when you guys are writing your own code, and this is really fun because when you're writing, you have a software supply chain. And this is a cool slide because if you're looking at the iceberg and you take all the code that is in your application, that is the little part that you actually wrote yourself, 10 to 20%. And that's the part SAS can focus on. But you normally only do 10 to 20% of your own custom written code. Open source code, that is 80 to 90% of the code database is open source, taken from Git, Maven, wherever. And the funny thing is 80% of vulnerabilities are found in indirect dependencies. So if you're looking at an external library where you're taking some code out of that library, that library has a dependency on another library and a dependency on another library. So when you actually scan it with a basic checker, it'll tell you that that piece of code doesn't have any dependencies. But 80% of the vulnerability is actually found in the indirect dependencies. So the dependencies that's not in the direct code, but which that code is dependent on. So that code is also dependent on another code, on another code. So that is really scary because if you don't scan that code properly, then you're still going to sit with 80% of your vulnerabilities because it's not in the direct code. 100% of Linux packages inherited from public sources, built, deployed, and scaled in seconds. So containers, we are deploying those things in seconds, and there's so much of it. And then your infrastructure as code is a big part down here. And now this is really interesting. Out of all the things in infrastructure code that can go wrong, the number one vulnerability is still misconfiguration. That is really scary. That misconfiguration is still such a big part. So when we're doing infrastructure as code, we need to be able to see what we're doing. I'm not going to go too much into this slide because I know Adam has this as well, but it really is important to understand where this all fits in. I think just on that one, I'm going to jump over to Adam's slide. Just if there's any questions, you can put them in, but I'm going to put over to Adam to do his part because this is really the interesting part, the part with the demo and showing you the lab. We can be good to start. Okay.
And I'm the security developer for us. I'm going to be giving us a brief outline as to what is the mythology of DevSecOps and where initially it fits in within the DevOps process that you guys might likely be already aware of. Basically, what we're going to be doing is we're going to be taking the standard DevOps mythology and plugging in certain automated security tools along the process. And I'm going to be demonstrating how on earth we actually go about doing that, and what these tools in specific actually look like and how they perform. Within DevSecOps, there is three main integration points that we are always wanting to integrate into to make life a lot easier for all of the clients and the developers working for those clients and those enterprise accounts. Within DevSecOps, we will use a term frequently used called shifting left. Now, what that relatively means is there was usually always a time where security came right at the end. So your developers are coding the application, they're compiling that application, performing the unit tests on it, and then sending it over to production in order for it to go live to the public. Now, it was the step just before going live to the public that the security test came into play. The problem was with this is that by that stage, it was always a little bit too late. Throughout the different areas, more and more vulnerabilities have been added to the process. And when you performed the security at the end, it was this big, massive whopping number, which, actually scared the hell out of most people, and most people didn't know what the hell to do with it. So you can imagine a developer who thinks that their application is done, it gets compiled and it gets sent through to the security team, and the security team come back and say, your job's not done. We've got all these number of vulnerabilities that we need you to go into and to fix, which you can imagine didn't make the developer a very happy person. So ideally, what we're trying to do is we're trying to move security into every single step from the beginning till the very end, making it this conjoined effort of everyone who is involved in the software development lifecycle to take on that role of partly being responsible for security. Where this helps is that slowly with each step, security tests are being performed and vulnerabilities are being remediated. Therefore, when it comes to the final security test at the end, instead of it being this great big whopping number, it's just a few tweaks here that they have to do in order for them to go live to deployment. So the first very step that we have is within our IDE stage. Now, IDE stands for your integrated development environments. This is the likes of Visual Studio Code, Eclipse, IntelliJ, Atom, and the list can really go on and on. There's massive amounts of IDEs for you to work with. Those that aren't developers, IDE is basically just a software which is a platform that allows the developer to write their code and can have a bunch of plugins for whatever the development language is that that developer works in, and can just seamlessly make the life of the developer a little bit easier while they're writing their code. The next phase that we want to integrate into is our SCM, otherwise known as a source code manager. Now, this is done to the likes of Gits, GitHub, Bitbucket. There's plenty of different source code managers out there. And what these basically do is it's a cloud space, can be offered through on-prem as well. But ideally what this is it's a space for all of the files that the developer has written to exist in one habitat, and multiple people within the development team itself can have access into this, see what other people are working on, and perform projects in layered approaches. Then finally, we have what is known as a CI/CD pipeline. If you have been involved with DevOps before, this is a term you very well would have come across. And this is continuous integration and continuous delivery. Now, what this allows for is basically from the point that the developer has written the code for the application through to the very point of it going live to the public on a web server. This is all handled automatically and it is configured beforehand with a set of instructions and a step-by-step scenario of what exactly is going to happen. And this is also where we can integrate security tools so that, in this pipeline, if an application goes through certain security tools and does not meet a certain security threshold, we can break that build and no longer allow that pipeline to continue, therefore eliminating that application that holds those vulnerabilities going live to the public. Now, CI/CD pipelines come in many forms. Azure DevOps, AWS Code Pipeline, Jenkins, Circle CI, Puppets. There's many of these, and if you've never heard of them, you've never played around with them, I would highly recommend trying to get a little bit of hands-on with these, whether you're in DevOps, whether you're a developer yourself, or just purely out of interest. These are things which you're going to be coming across a lot of in the future. And they're quite a revolutionary product. So I would highly recommend having a look into some of these. Now, natively, what a CI/CD pipeline was used for from a DevOps point of view was the developer writes his code for a certain application, happy to go ahead with it. That will then be pushed into a CI/CD pipeline, and the CI/CD pipeline is going to perform a static set of tests. Those being, it's going to build that application. Say if you're working with a Java application, it's going to be built using Maven or so on and so forth. So that compiled application is then going to be sitting in binary. Binary, you want to store those artifacts onto a cloud storage like Artifactory, JFrog, all that sort of stuff. You then want to perform UI tests on that application to make sure that the application is actually running the way that you want it to be. And once you have the green lights on all of those, then it's eventually going to go and it's going to be deployed into a web server where clients can actually interact with it. So that is the general DevOps methodology. All of that stuff happens automatically and has no human involvement whatsoever. And this is great for companies to assist with time to market, especially for those types of companies which are, releasing multiple updates, not even many times a month or many times a week, but sometimes even places like Facebook and Google, which are doing updates on the daily or on the hourly. Now, finally, when we look at a modern-day application, we'll find that it's generally made up of these 4 different components. So at the top, we have the custom code, which is the code the developer writes himself. Underneath that, they are then leveraging open source code, bringing in that functionality that they don't necessarily have to write themselves. These 2 components of the custom code and the open source code generally then get deployed onto a container, and infrastructure as code will tell that container how to behave once it's live. Now, a lot of you may be thinking, what really is open source code? And if we are using open source code, are we using a lot of it? Now, maybe about 20 years ago, you would have found that if we were looking at an application, majority of the code that was used to make the application work was having to be written by that developer or that development team. Nowadays, not really so much the case. Thankfully, through the likes of open source libraries, a lot of the functionality that we're needing for applications that can be easily replicated is stored in open source libraries. Therefore, we can bring in that functionality that we don't necessarily need ourselves. So we're looking more at a split nowadays of 20% of the code within an application being developer written code, the other 80% being made up of open source libraries. Now, that's great. However, through working with open source libraries, we can also bring in a lot of stuff that we're not necessarily aware that we're bringing in. Using one open source library, you may think that you're leveraging only one, but you might be leveraging about 50 in the background. And this can really open us up to a whole new other world of vulnerabilities and possible exploits for hackers to take advantage of. So definitely areas to be aware of. So what we would generally classify these in terms of AppSec security tools our custom code, we are looking at a SAS solution, which is our static analysis security tooling. Then we have our SCA, which is our software composition analysis, which is a tool purely dedicated at scanning vulnerabilities on open source libraries. We then have container scanning, which, as we know, containers are made up of a base image, which is in a way similar to an open source library. You know, it is generally something that you are pulling from online that was previously made and has a basis of a certain set of instructions. Again, those need to be checked as well. And then the configuration on your deployment files, which has to do with your infrastructure as code, whether that's deployment.yamls, Helm charts, Terraform, anything like that. We need to make sure that our configurations there are as secure as they possibly can be, as that is our final step before actually going live with the product. All right. Now, if we have a look into my screen now, I have open for us a IDE that I regularly use, and this is Visual Studio Code. So what I have done now is I have simply integrated one of our static security tools by the name of Sneak. Majority of these tools that plug into your IDEs are super easy to do. These can easily just be done through your extensions pad. You find the name, obviously, for the licensed product that you bought, as you will need API keys to certify that you have bought these. But then you will notice that all of a sudden we have tabs that will start doing scans on all the different files within your application, and we can easily just have a look into these and we can see exactly what's going on here. So this is having a look at the open source libraries that I'm using in this. We can see that I have introduced vulnerability using PostgreSQL 9.2, and if I update to 4.2.2, that will easily be fixed. So it makes it nice and easy for the developer. All I have to do is simply click into here, and I can have a look. What is the vulnerability? Well, what is the library that is being affected? What version is the issue? And what version do I need to upgrade to in order to fix this? So I can easily just go into my POM file and just quickly update for us, and that vulnerability will be eliminated. Along with that, also just a quick overview just to see what exactly is the issue with this, what type of attack can occur from it, and just give a little bit of intelligence and education around why this is an issue. So we can just be aware of this as the development team and try and eliminate it moving forward, as we want to avoid as much repetition as we possibly can. All right. So over here, I have opened a repository. I use GitHub. Again, just so you can see, this is just a cloud-based platform just for the files that you use within the development of the application. And we can simply perform a scan on here as well, just to get a quick overall view on exactly what is happening there. All right. So as I made mention, DevOps is all about CI/CD pipelines. And this is one that I natively use by the name of Jenkins. And what we're doing here, again, like I say, it's simply just every, say, 5 minutes, 10 minutes, it's linked to one of my GitHub repositories. It's checking it every now and then to see if there's been any changes made to the files themselves. If it has, then it's going to trigger these specific steps. So like I say, natively, what you'd be doing here is you would be compiling an application, you'd be storing the artifacts, performing some UI tests on it, and then eventually going live to production by sending it over to deployment. Now, that's all great and well from a DevOps point of view, but now remember, we are going to have a look at DevSecOps. So how can we integrate security tools into this that it has completely hands-free from any human interaction whatsoever? So if we have a look at step 3 and step 5 on my Jenkins job that we are running over here, you can see that I'm running a sneak test over here, which is going to be looking at those 4 components that I showed us earlier on that iceberg diagram. So we're going to be looking at the developer written code, any open source vulnerabilities that may house any dependency issues. We're then going to be having a look at our containers and then our infrastructure as code for our deployment files. Finally, the 5th tool that we're going to be using is HDiv. Now, we have not touched on the specific AppSec tools that are involved that aren't in a static sense. So these would be more what we refer to as dynamic security testing. What this really means is everything that we have looked at before was from a static point. What that means essentially is that it purely is just static sitting code. It's not running, it's not being used by clients or anyone like that. It purely is just static files of code sitting in a folder somewhere. And that's all it's having a look at. Now, once all of that moves over onto a web server and it's client facing and it's running on the internet, that opens us up to a whole different category of different possible vulnerabilities. So we want to be having a look at 2 things over there. We want to be making sure that if we have any vulnerable packages on that web server and how our application interacts with that web server, if it's picked up any vulnerabilities or common exploits there. The other thing we want to have a look at is, remember, now that it's actually being interacted with by other users, we're potentially opening ourselves up to the possibility of hackers, because not everyone's going to interact with our application with the way that it was initially intended. So we want to make sure that we can view what's going on there and we can set automatic blocks to potentially anyone that's trying to cause harm to this application. So let's go ahead and let's have a look at our 2 different dashboards that we are seeing. So let's go ahead and have a look at Sneak first. So we've run that Jenkins job, it's performed the Sneak scan, and here are our 4 different components that we saw earlier. So we have our code analysis, which is our developer written code, our package.json, which houses all of our open source libraries, our Docker file, which is our container, and then also our deployment.yaml, which is our infrastructure as code. Now, if I'm the developer, I'm going to be interested in the code that I've written. I want to see if I've introduced any vulnerabilities there. So let's go in and let's have a look. Now, a great thing about this tool as well is it gives us all the vulnerabilities, but on top of that, it also prioritizes them for us, meaning it's going to set which security severity these are sitting in. But along with that, we might also have 4 or 5 different high severities. It's still going to prioritize which one of those are most important to fix first. So we don't necessarily have to come in here and do all of that work ourselves. These tools are amazing enough to come in and do that all for us. So we can see here, we're sitting with a few different high severities. Now, it's all great and well, it tells us where the vulnerability is, but now what on earth is this and how do I fix it? So again, these tools are amazing in the sense where it shows us exactly where it is, what is the file, what is the line number where this is affected. And if we go over here, we can get a full set of education on exactly what a SQL injection is and how we can, in the future, go ahead and prevent these. So again, what's amazing is what we're trying to do here through DevSecOps is not just give someone a huge list of vulnerabilities, but we also want to educate them on what these are and how they can avoid them in the future, therefore eliminating the amount of vulnerabilities that we're getting over time. On top of that, we're not just saying, okay, you've got an issue, this is what it's about, but good luck to you to fixing it. It's as simple as we give you the exact line of code as to how you should change it, and that will eliminate the vulnerabilities. So if I was the developer, I would just come in here, I'd see the line that's affected, I would change it to what it needs to be, I'd resave it, it would go through the pipeline, and now it would pass. All right, so that's what we're getting from a Sneak dashboard. Now let's go ahead and have a look at what we're seeing from HDiv. So now everything's passed, it's gone through, and it's deployed it to our web server, and it's client facing, and it's running now on the internet. So it's again giving us an idea here as what are the different types of vulnerabilities that we are seeing within this running application, and we can get a great idea as to what we need to be working on in order to improve our security posture over time. Now, what's really amazing about this tool is when we come over and we have a look, apologies, when we have a look on the attack field, you can see all attacks. So we can also get an alerted list as to any types of attacks. As you can see, someone has tried to perform 3 different types of SQL injections over here, and this is exactly what they were trying to use as a string as well to try and make the possible exploits. And on top of that, we have some different options that we can set here as well. So we can completely turn this off. We can turn it more into a bit of an alert mode as well, or we can actually put this technology into the most powerful situation that it can be in, which is in its active running mode. Therefore, the moment someone tries to actually cause this exploit by inputting this string, it's going to come up with an immediate blocked error message on their side, stopping the person in their tracks. It's going to give us that information as well through HDiv, things like the IP address, the type of location that this has come from, the type of attack that they were trying to perform, all the types of things that are going to assist us to prevent this from happening again and possibly trace the tracker himself. But the main thing is we want to know about these things before they've been able to come in and possibly cause any harm to our running application, which is absolutely incredible. And yes, guys, that's just a bit of a brief overview as to what DevSecOps is, the main points of where we want to integrate, and just a little bit of fun as to what these types of tools look like and what the possible potential is of really securing an application to the most that it can be. I hope that was great for you guys. I hope you got to learn a little bit more about DevSecOps today, and we've hopefully inspired some future ethical hackers and security analysts via our demonstration today.
All right, guys. Yeah, I think if Adam was on, I'd say thank you very much. Just trying to quickly get out of the screen. Okay. I see there was a question about how do we introduce DevSecOps culture into an organization. David, this is actually a really good question, and this is one of the things that we focus on a lot, because one of the main issues that we get is trying to actually get the organization to adopt DevSecOps. From a security point of view, we know we want it. We know we want the guys to give us all this information. But from a developer point of view, they normally see this as a blocker. You're trying to slow them down. You're going to make the releases slower. And if they start kicking back, you're not going to get anywhere. Doesn't matter how good the tool is that you're trying to implement, they will make it fail. So what we do is we focus on the developers first. We say developer first, as Adam's also showed in his apps, developer first. We want to make sure the developers see the value, and we're not trying to make them look bad, that they can actually have tools that they enjoy and that adds value to them. So, but this is a process that we go with you with the client. So we go with the client, we say to them, okay, what are you trying to achieve? How do we assist there? There's a questionnaire I send to my clients so I can first determine what is the most important things for the organization, because each organization is different. So once I determine that, then we can determine how we're going to get the organization to introduce a DevSecOps culture. But it is a very good question because it is one of the most difficult things to get going. Any other questions, guys?
No, I haven't seen any other questions. There is one from Azim saying, when coming to the DevSecOps, how do we get started? What do we tackle first?
So it all depends what you have in a developer focused environment at the moment, but I would start with the left. So when we say start left is first look at the processes, as we mentioned, but then if you're looking at tooling, what to start with, you start with the SCA. You start with the code that the guys are externally downloading. That's the first step that they're doing, they're downloading code. Then they're writing code. So then you look at SAST. Then we want to look at a DAST, where we're actually running the application, or an IAST. Once all of this is complete, then we start going into IAST and cloud configurations and all of that. But for a beginning point, you start looking at the code they're writing and the code they download. Because if we can make sure that they're not downloading vulnerabilities from external code and they're not writing vulnerabilities into the code, your first step is already a lot better. Yes, then there's going to be integrations and there's going to be configurations and all type of other stuff to look at. But for a starting point, let's first make sure that the code is correct. We've done code reviews. We know that the code is secure. Then we look at the next step. That's where I would start. Any other questions, guys?
Hi. Okay. Yeah, I actually have a question. It's Nancy. I have a question. Yeah. I wanted to ask infrastructure as a code, what some of the best practices for organizations in regards to that?
So infrastructure as code, I'll send you some of the best practice afterwards. But infrastructure as code, it's really important to have a tool so that you can have visibility. The important thing there is the visibility of what you're actually deploying and using when you're doing infrastructure as code. And this is a big problem when people don't have visibility and the developers are doing things that you don't know about. So having this tool here is really important. Something that gives you visibility so that you can manage what the guys are doing. You can put security gates in and rules to say, we're not allowing this to go out. This actually leads nicely into the question from Davis. How do we deal with resistance from developers for integrations? Davis, this is my daily fight every day. The best way that I find is to find tools that they like to use, something like a SNCC and an HTIV. Find something that actually teaches them something. Someone wants remote control of the screen. Okay, sure. No, not going to work. So when we're doing with developers, as you know, developers are very finicky, and if we can show them that this will not slow them down, it will add value to their process, and it will actually make it faster, then they will buy into it. But it is something that we need to work on and say, developer first. We go to developer, we show him the value, we show him what we're trying to achieve. We do not go with him and say, you have to do this. You will do this because I need this report. If you follow that route, they will kick back. And if the developers want to make the tool fail, okay. I'm not quite sure. Can everyone hear me?
Yeah.
Yes, we can.
All right.
Yeah, you can proceed.
Okay. Any other questions, guys, or shall we go to the Kahoot? I see we are running out of time.
Okay. I have one question.
Yes, Mike.
In where the SAST sits in the whole build, run, deploy scheme, should the SAST sit in different, like should it sit in a place probably at the commit or the code commit side, or should it sit at where probably the package has been compiled to an extent? Could you please advise me on that?
So a SAST it needs to be done before you're compiling the packet. Once you compile it and you're actually going to run it, you'll use a DAST. So it all depends on how often you release. If you're releasing code and you're writing a lot of code and you're releasing it regularly, I would suggest that you shift it as far left as possible. So when the developer's actually writing code, you check it on a daily basis or on a hourly basis as he's writing it, real time, check his code. So you can fix it as he goes. later you do your SAST scan in the process, the more vulnerabilities you're going to find to fix. So if you do it on a daily basis, you have 5 to fix. If you wait until the end, just before deployment, you might as well have just done a pen test, because you're going to find all that flaws at the end and then go right back to the beginning. So it's not going to make the process faster if you wait until the end. Does that clear it up, Michael?
Yeah, that's clear. And also from vulnerabilities that might come from an application just running, probably it has passed the commit side. And thank you for saying that you should make sure the SAST sits as far left as possible. But
Yeah.
when
Also,
it comes from application just running, are those vulnerabilities from the code side or just from the application just running? Will the SAST assist with that?
The SAST is not going to look in the runtimes. So the SAST looks at your custom code. Now, remember, if your custom code is written securely, very rarely will there be a new vulnerability included. In the vulnerabilities that gets included in your runtime applications, those are from external code that you've put in, and we now see there's a vulnerability in that versioning that was done or something like that, and we'll alert you about it. Or there's a new vulnerability that we're aware of, we run it in runtime and see it's in your code, then we'll pick it up. But that won't be a SAST tool. The SAST only looks at the code that you write. And that's why we say it has to be as far left as possible, because you could fix the code, and then while fixing it, you're actually writing a new vulnerability. So as far left as possible so that we can fix it as we're writing the code. The runtime, you'll use a DAST or an IAST, which has runtime capabilities. And that is where you'll actually get the benefits of how the application is behaving, if it's doing something it's not supposed to, looking at new vulnerabilities in OWASP, whatever, to see if there's anything that's now suddenly in your code that wasn't there. But it's not going to be the SAST that does that.
All right, thank you.
And you'll see a lot of clients use SonarQube for SAST. And SonarQube is actually a code quality tool, not really a security tool. You can use it to do security, but you really have to do a lot of customization. So when clients say to me that they have SonarQube, I always have to go and look at the configuration, what they did to use it for security. And this is also back to your developers. Your developers will say to you, no, we have SonarQube. Here's the report. We've done the testing. You've done code testing, not security testing. So the developers will give you that to tell you, no, it's fine. Don't worry, we checked it.
And then we've got another question here from Denzel saying high-level use cases that a SOC can use to integrate their daily monitoring at a large enterprise that looks into leveraging the IAC. And then what is the inherent risks that come with IAC?
So integrating into a SOC, finding use cases for that depends on the organization and what they actually want to look at. When we're looking at anything from the DevSecOps side, whether it's IAC or earlier, it really is more on the security gates. So if someone's introducing something in the code and it doesn't meet your requirements, that's basically when we'll feed it into the SOC and let you know these developers are about to release or have released something that isn't meeting your business minimum requirements or your security risk measures. So that you're aware that they've done something that they're not supposed to. You could block it, but sometimes it is a question of the developer needs to get it out. It needs to go into production. And you just want the SOC to be aware, okay, this is out there. We need to check it because the following vulnerabilities is now introduced. So we need to monitor if something does happen in our SOC. So it's for information purposes. I can get Adam to reach out and give you more information on that. Unfortunately, that is a bit more technical to actually see how we introduce that. But we're happy to set up more sessions with you guys individually if you reach out to Shalom and them, and we can go into this in detail.
I have also posted Franco's email address in the chat if anybody would like to reach out to him directly as well.
Right. Okay, guys, any other questions, or we're going to do the Kahoots? I see there's a couple of people that joined, but there's still time for everyone to join before we start. Audrey's given us some nice prizes. The first prize will be a Bluetooth speaker, and 3 for a Bluetooth speaker for the individual, and for that company, 3 free training vouchers on one of the areas that we've discussed today. So one of those areas you can take a free training voucher, 3 free training vouchers. So the company will get 3 training vouchers and the person will get a Bluetooth speaker. Second prize is a power bank for the individual and 15% discount on services from DRS or on the DevSecOps if you buy any services from us for the company. And the third prize, unfortunately, is just like a normal pen and a notebook and some office stuff, which is still really nice, and a free assessment for the company. So this is where we do an assessment to see where you guys are and what you need to do, which is also really nice to just say, from a DevSecOps perspective, security-wise, where are we and what do we need to do and where do we need to get? So I think, Audrey, thank you very much for that. But yeah.
Been a pleasure.
Once we have everyone on, we can start. Maybe if there's only 4 questions, it's a very quick and easy one. I just wanted to have some fun. So let's just maybe give 3 more minutes for everyone.
Franco? Oh, okay, wonderful. There we go. Don't worry.
Yep. So I think what also was really cool about what Adam showed us is to show you guys that when you're actually looking from a developer's point of view and you see these tools, you can actually see how to fix it, what you're doing, and you start being a better developer. And this is something that really helps getting the developers on board, because developers look at functionally to code. So when I'm doing a piece of code that has to do something, does it do it? So when I type in this, does it give me the balance? Does it? Yes, functionally the code works. Security-wise, it has some vulnerabilities. But the developers for the last how many years have always gone in to say, we need to write functional code. Nobody's ever taught them to write security code. Now we're coming in from a security point and telling them, you have to do this, you have to do that. They are going to kick back. But if we work with them and say, show us, let me show you the value. Let's do it this way. Let's do it that way. Guys, then it's where they come in and they see the value and they start working with you. Believe me, they are also very interested in security. They want to write good quality, secure code. It's just the way we approach them. And once they see that this is actually a cool environment with nice tools, you get a lot of value out of it. Okay, we're on 16. So my Kahoot can only take 20. So once we reach 20, we have to start anyway. I did not expect this many people on the session, but it's really, really great to have that many people interested in DevSecOps. I can tell you in South Africa, when we have a session, we get 10 people, we're lucky. So it's really great to see so many people interested in this. And I hope that the session was worthwhile and that, you know, you got value out of it, because guys, really reach out to us, tell us what you need and how we can help you. We'd love to have more in-depth discussions with all of you regarding what your specific needs is. And that's what we started off with, to say to you guys, DevSecOps is specific to each customer, because everyone's different space of their journey of DevOps and a different space of what they want to achieve. So we'd like to have those individual discussions with you guys. Okay. Should we start? We're on 16.
I think you should go ahead and start.
All right. Okay, guys. Everyone has played Kahoot. Kahoot, it's 4 questions, really easy, fastest one to get them right. It's not difficult out of the questions that we did get, guys. So wait, 19. All right, guys, we have 5 minutes, so we're going to start. 1, 2. Sorry, there we go. Okay, DevSecOps. You have 20 seconds on each one. How much of the code do we use is custom? So when we have custom codes, how much of it is custom? 10 to 20, 30 to 40, 50 to 60, or 70 to 80? This is that first one we showed you. Yeah?
10 to 20%.
You mustn't say it. 7 right, 2, 5. So I think that one, maybe a lot of people got to think that it was the code that we were getting externally. No. So the code we use that's custom, writing ourselves, that's 10 to 20. All right, so JDog is in first place. AZ second and EC third. King Midas is close on fourth. Okay. What is the #1 cloud vulnerability? Is it SQL, improper access control, user credentials, or misconfiguration? It's really, really funny with all these stuff that could go wrong, that this is the one, as I mentioned. All right. Oh, it's misconfiguration. Only one got it right. Sorry, no, 13 got it right. One got it wrong, 2 there. Misconfiguration, that's correct. Yes, great, guys. Let's see how this changes stuff. JDog, EC, Ace, still King Midas just behind him. All right. What does SCA stand for? Secure Code Analysis, Software Composition Analysis, Super Coding Analyst, Supreme Court of Appeal. It's software composition analysis, guys. I put secure code analysis there to see if we can trick you guys. It's software composition. It's really important. This is the one for the external code, which we spend so much time about, software composition analysis. Let's see how that changes things. Not much. All right, and the last one. What does CI/CD stand for? Is it collect info, collect data, code inspect, code deploy, cloud interface, cloud data, or continuous integration, continuous delivery? This one, I'm assuming everyone will get right. I think the problem here is also you try and go quick, so you click something before you actually meant to click it. There we go. Continuous integration, continuous delivery. This is a term that really gets used in the DevSecOps and the DevOps environment a lot. All right, so let's see the podium. AZ, third, second, EC, and first, JDog. Guys, thank you very much for joining. If you guys can, I see DevOps and Bazu has moved up to 4 and 5. Guys, it'll be great if you can just reach out to either myself or to someone from SheHacks or to someone from Protec so that we can get the prizes to you.
To the top 3 winners, can you please direct message the SheHacks account with your details, and then we'll pass them along.
All right. Thank you so much. I really appreciate that. Okay, guys, that's it from my side. I hope you guys all had fun, and I hope to hear from all of you soon.
Thank you guys for joining. Thank you so much, Frank, for being an amazing guest. You were the session was very insightful, and thank you, Adri, for also helping facilitate our meeting. We are so appreciative to have you guys here, and Shalom for arriving on time and making sure everything was good. Thank you so much to our participants. I know it was difficult to attend during the December holiday session, but you made it anyway. So thank you and good night. Please don't forget to DM me to the winners. You need to direct message me, or you can reach out on the SheHacks Twitter page if you forget.
Thanks so much, guys.
Thank you, everyone.
Maybe I would say something before we conclude. On behalf of the SheHacks team also. A big thanks to everyone who has showed up, and to Protec for organizing this, the DNS team. It's been really insightful, and I look forward to hosting you once again for another amazing sessions, because I believe this will be so insightful, not only for our community program, but also for the campus edition. So thank you so much. I'm looking forward to keep in touch.
All right. Thank you so much, guys.
Thanks, everyone.
Okay, bye-bye.
Bye.
Bye, everyone.